Hello!
Ben, hello. Hello, Saab. Hello. Welcome. We are here with this beautiful Olympic question. Now, when we first look at the question, okay, Saab, it looks like the difference of two squares. What do I mean? Let's do it this way. We can think of this problem as 1 over 1 squared minus x squared. If I expand this integral a little, I get 1 over 1 minus x squared times 1 plus x squared. Now, what do we know here? We know that the sum of 1 minus x squared and 1 plus x squared is 2. Look, I will use this. How will I use it? I will multiply and divide this integral by 2. What do I mean? I say 2 over 2. Now let's continue. What will happen? Of course, I can bring the 2 inside. Then, if I want to write this where I see 1, what happens? 1 plus x squared plus 1 minus x squared, hop, divided by 1 plus x squared times 1 minus x squared dx. Now, due to the property of the integral, what can I do with this? I can separate it. I can write it like this. Here is 1 over 2, open parentheses, integral 1 plus x squared over 1 plus x squared times 1 minus x squared.
Let's say 1 minus x squared over 1 plus x squared times 1 minus x squared.
After closing it, what can I do with the dx here? I can add it. Now, if you pay attention to what happens next, there are similar terms both in the numerator and the denominator. These will cancel each other out. They're gone. Then those are gone too. Yes.
Now, if we continue, what do we have left? 1 over 2. Yes, these are gone. 1 over 1 minus x squared. Plus 1 over 1 plus x squared remains. Let's not forget to write dx. Now, again, if you pay attention to this part, what did we do at the beginning? We multiplied by 2 and divided by 2. We had obtained this. We will try to do this again with the same logic. Then let me multiply and divide this expression by 2 again. Now, if I want to write it, what will it be? But before multiplying, let's distribute this a little. Wait. If we do it like this, it will cause us trouble. Let's distribute this 1/2 over it initially. When we distribute, it becomes 1 over 1 minus x squared dx plus 1/2 integral of 1 over 1 plus x squared dx. Now, what do I need to do with this part using the same logic? I need to multiply by 2 and divide by 2. I continue. So, if I apply this operation, because what do we know? Again, I know that 2 is equal to 1 plus x and 1 minus x. I will use this. I continued. Now, if I multiply this, it will be 1 over 4. When we multiply these two, it becomes 1 over 4. Then the integral again 1.
The top, yes, I can write the top like this with the same logic. 2 over, 1 minus x. Again, I open the difference of squares here. I say 1 plus x.
So, I said dx. Then I continued. 1/4 integral. What am I doing with these two places I see? 1 plus x. Then I write plus 1 minus x over 1 minus x times 1 plus x
Again, of course, this is dx. Then again, one of the fundamental properties of the integral. What can you do with this? If the denominators are common, you can separate them. 1/4 integral. Of course, let's use a root parenthesis here to avoid any issues. So 1 minus x over 1 minus x times 1 plus x. Then, so 1 plus x over 1 minus x times 1 plus x. We closed it. Then again, what did I say? I said dx. Then, if we continue, look, again, here there are expressions that cancel each other out. What will happen to these? They will cancel each other out. Bam, bam. These are gone. So what has the expression turned into? 1/4. We continued again. Integral 1/1 plus x. Yes, plus, what does it become? 1/1 minus x. I close it. What happened? Dx. There are places somewhere around here, right? Yes, let's continue from here. Let's draw it like this. Now, what will we do with this expression we found? Of course, we can now take its integral. Now, what were we? Let's recall the integral of ln x, the integral of ln x. What will happen when we take the integral? It will be 1/x. With the same logic, if we consider this, I can write it like this. What was the final form of the integral? 1/4 integral of 1/1 plus x dx plus 1/4. If we continue, the integral has become 1/1 minus x, right? I didn't write it wrong. Yes. Now we will take the integral of this. If I take the integral of this, of course, there's also the x here. Let's not forget the x. What happens if I take it? It will come as 1/4 times ln of the absolute value of 1 plus x. Now, there's a minus part here. Look at this. So what do I need to do with this minus? I need to bring it to the front so that it becomes positive. Then I will say minus 1/4. So ln, what happened? It became 1 minus x in absolute value. Now, we solved this part of the problem. But where was the main part of the problem? Look, where is the main part? Here. So what has my question turned into? When we cut this from here, it becomes 1/4 times the natural logarithm of the absolute value of 1 plus x minus 1/4 times the natural logarithm of the absolute value of 1 minus x. And finally, what will we do with this one? We will take its integral. I think you all know this expression. What was this expression? It was arctangent x. So what do we write here immediately? Plus, I say plus here, arctangent x. And what else does it have? It has a c, let's not forget. So what is our answer, friends?
That's it. It was a very nice Math Olympiad question.
I hope you found it useful. Please don't forget to like, comment, and follow this. Now, my request from you in this part will be this. I hope you liked the video. Please don't forget to follow and like. See you. Bye-bye.